Hey everybody, we're back again for another C++ lesson. I have my son Alex here with me. How's it going, Alex?
Hello.
Yeah, great to see you
Sorry for
again. What's that?
yeah. Sorry for being gone.
Oh, that's all right. That's all right. You're back, and we're back, and we're excited to get into some more C++. And today we have another really important tutorial. I know every week I say it's an important tutorial. These are
Yeah, pretty much.
all of these things are important to know. This is a really important one as well, and it's one that scares so many people. But what I'll show you is that it's actually not that scary, and this is a concept that takes a little bit of time to learn about. But what we'll do is we'll start from a foundation of stuff that we know, and we will build up from our foundation. And the subject today is going to be pointers. So this is something that intimidates a lot of people. And what I'm going to show you is that you already basically know what a pointer is in its very basic form, and that we will use that to really build on our foundation. So yes, so today is lesson 6. We're talking about pointers, and this is a general introduction. So this will be a pretty short one, and this will be one of several parts. We're probably going to continuously be building on the base knowledge that we've started off with, all of these things like pointers, references, classes. What I'm giving you right now is just the very, very bottom layer that you need to know. And then as we move forward, we're going to continue to build upon these very basics. So here's our overview. This is what we'll talk about in this lesson. We're going to start off with some very high level thinking. And then we're going to take that concept and we're going to turn it into code. And then we will do a practical code walkthrough. First thing that we're going to do, though, is a very quick review of something that we've already covered before, which is references. Okay, so let's say that we have an int, and I make an int a, and I set it to 2. In one of our previous lessons, we said that we can make a reference where we can take a reference and we can set it to something that already exists. Right? Do you remember that, Alex?
Yeah, I do remember that. Yeah.
Yep. So, and one of the key things that we talked about was that we can't create a reference that doesn't refer to anything. So if I do this with C, we see that it requires an initializer. Okay, and going back, we said that B is really what we call an alias or referencing A. So anything that we do to B will also happen to A, okay, because it's referring to the same space in memory. And that's all a reference is referring to one particular quote unquote box. That's what we've called it in the past. And in this situation, we have this box and its value is 2. But if I say b equals 4, and then I console out what a is, what do you think a will be?
A will be 2.
A will be,
Yeah. No, 4. It'll be 4 because you changed B.
that's right. Yeah. So exactly. We see that b is 4. Let me make this a little bit bigger for you, for the people that are watching. So we see that b is a reference to a, and anything we do to b will happen to a. Okay? So that is what a reference is.
Right.
Any questions about that so far?
Seems pretty simple.
Okay, great. So now, with that review, this will bring us forward into what is a pointer. Okay, so what is a pointer? And a pointer is the same thing as a reference. Okay, in that it refers to a specific place in memory. Okay, it refers to a specific box, and that's all that a pointer is. Pretty much exactly the same thing as a reference. Okay, except a reference has to refer to data that already exists. So when we were going back to our previous example of what we did, where we had the int reference C, and then we didn't initialize it, we got an error because it said that it has to be initialized to something. A pointer does not have to be initialized. Okay, so it could be pointing to nothing, essentially. And also, one of the big things that we need to do when we're talking about pointers, or when we're trying to look at the value in a pointer, is that we always need to make sure that the pointer is actually pointing towards something before we try to use it. Okay, so I will show you how to do that in just a moment. Okay, so any questions on that specific concept so far?
So this was something we visited briefly in another lesson, I believe, was it?
Yeah, we touched on it briefly. Yeah. So the big difference the big difference that's important to know at this point is that a reference and a pointer are the same thing, except you can initialize a pointer without it having to point to anything. A reference has to point towards data that exists. Okay?
But other than that, they're fundamentally the same.
Yes. Okay. So now we're just going to compare the syntax of a reference versus a pointer. Okay, so here we have a reference example, and in this one we have a reference to some class that we created called a video. So let's say that it's high definition video. We don't want to copy it, because if we said video and we did not put the ampersand out after it, it would just be a local copy that would happen within that function, right? Do you remember that?
Right.
Yeah. So when you have
something,
yeah, go ahead, Alex.
Yeah, you wouldn't want two videos because that would take up more memory.
Exactly. So if you have a video that's occupying 2 gigabytes of space and memory, to copy that again would take a lot of processing power. And so what we want to do is we just want to reference that space and memory where that video is being held. And then from there, we could do some sort of video processing. Let's say we wanted to turn the video into black and white from a color video. So now we're going to look at the same thing, but doing it with a pointer rather than a reference. And there is just one key difference. So let me move your video here because you're blocking my presentation. You probably can't see what I'm talking about. But let me go back here. Okay. So we have this video, and now we have a video pointer rather than a video reference. Okay. And then we open. The key difference between a reference and a pointer is that we need to make sure that the video is actually pointing towards something before we try to process the video. Okay? So that's the main difference between a pointer and a reference. Okay? So a pointer does not have to necessarily be pointing towards any video. Or we can make it change where it's pointing towards, or it could be pointing towards nothing. But the big thing to understand here is that we do not want to try to call processing on a place that is pointing towards nowhere, right? Because then we run into this terrible thing called undefined behavior, which is essentially a phrase that you will hear in various coding circles, where it basically says, if you do this, we don't know what's going to happen. Your program could crash. It could do something completely unexpected. We don't actually even know what it's going to do. It's called undefined behavior. So yeah, go ahead.
Isn't that what you called dividing by zero?
Yeah, so dividing by zero is another situation where if if your compiler were to allow you to divide by 0, then you would run into this undefined behavior territory again, where we don't know exactly what would happen. Okay, so yeah, so there are certain things that happen in your code that you want to make sure that they're valid before you try to do a process on that. Okay.
Mhm.
So let's have a look at a practical example, and this is really just a gentle introduction to pointers, and there are so many different things that I can talk about with them, but we're just going with, from now we're just working from the frame of reference of a reference versus a pointer, and then later on we'll go a little bit further into working with pointers. So let's say that we made a class and we called this audio track. So we have some sort of audio track that's holding a song, right? And what have I done here? So I don't want these braces here. So this is an audio track, and we can just say this represents a track. And then let's say that we created some sort of method that was going to analyze the track and figure out what the levels of the track are, right? So let's make this as easy as possible. So we got some sort of method called void analyze track, and this is going to take an audio track pointer, okay, and then that's it. That's all we have so far. So let's actually make it a reference to start off with. Okay. And so what this would do is then figure out levels of the track, right? So now we want to create an audio track object. Okay, so we could say audio track track, and then here we would just say analyze track, and we want to put in our track, and that's it. All right, now if we compile this should compile fine, and we see we get build succeeded. Okay, so it's not really doing anything, but so I'm calling upon you and people that are watching to kind of use your imagination a little bit. We're just creating a very simple, naive example of how we actually use these in code. Okay, so any questions so far on that?
So this is kind of a broader question, but can you end a program if a null pointer hasn't been resolved? And what I mean by that is it hasn't actually pointed to anything.
Yeah. So when you have something that you've created that is just a null pointer, it's not pointing to anything, and your program runs, and then you don't ever. This is getting more towards what we're going to cover in the next lesson. But if you don't ever do anything with the pointer, then and you just end the program, it doesn't do anything. Like it's fine. Oh. But we're going to talk. That's kind of creeping more towards what we're going to cover in the next lesson. So
sure.
So hold on that thought. So now what we want to talk about is just how we would use a pointer if this were to be an audio track pointer rather than a reference. Okay, so one of the first things that we need to do is we always, if we're passing in a pointer, we need to make sure that the track is actually pointing towards somewhere. Okay, so that your pointer is actually pointing towards a piece of information that's a valid track. So you could do like I showed you in the presentation. So you could say if track is not equal to null pointer, and then I'll show you 2 ways how to do this. And then here we have this, so that will work just fine. Okay. Another way that you could do it is you can actually just say if track like that. So because track is a pointer, and you can just basically say if track, meaning if track is not equal to null pointer. Both those things mean exactly the same thing. Okay. I like to use if track, but some people like to explicitly say if track is not equal to null pointer. So we will just keep it like that. Now comes the part of, need a P in there. There we go. Now comes the part of actually passing in the track into the analyzed track. Okay. Now, a pointer is supposed to point towards a memory address, right? So when we're passing in a pointer, what we need to pass in essentially is a memory address into this when it's asking for a pointer. We need to point it towards a memory address. Okay, need to point it towards a box that's holding our track. Okay, so do you remember how to point it towards a memory address? What we need for a memory address, Alex?
To be honest, I don't remember. I know you had to append something to the actual variable, but I don't remember what it was.
Yep. So we need to prepend it with an ampersand. Okay. So like this. Okay. So that is how you that's how you prepend. That's how you give it the address of track. Okay. So just to review really quick, if I say int ampersand, that means reference to an int. If I say ampersand, my int, that means the memory address of my int. Okay. And if I say int star, that is pointer to an int. Okay. And then I'll put another caveat in here that may not be pointing anywhere.
So in the instance that we have something to point to, is there any reason to use a pointer over a reference or vice versa?
Yes, so you bring up a great point, and this is something that we will talk about further in depth when in our next tutorial. But the big idea here is that some things up to this point, everything that we've created, everything that we create when we compile is already existing when we actually run the program. So we already have an audio track that exists, and that we pass that in to our track. But when you start running larger applications, there are going to be times where you want to create things that don't exist at the start of your program. So, for example, let's say that you're producing a track in Ableton or in any sort of DAW. Just the process of creating a track, creating a MIDI track or creating an audio track, if you didn't use pointers, then what would happen is that you would have to already create a load of tracks that would be sitting in memory. You'd already have to allocate all of this memory that would hold these potential tracks, but you're not using them, right? You would have to, let's say that the max number of tracks in Ableton would be 100 tracks. If you allocated that, if you were doing it without a pointer, then what would happen is that you would have to have a load of tracks that you create. So let's say audio track isn't a quote unquote audio track anymore, but let's say that it's an audio track in Ableton, right? So in this case, I'd have to do something like this. We haven't covered how to create collections of of these things so far yet. So this is how we have to do it. But you would have to create a load of, essentially you'd have to create a load of these before you've actually compiled your program, because you have to have all that space allocated. Right. Now, what a pointer allows you to do is it allows you to create things that aren't existing at the start of your program. So like, so looking at a high level example, let's say a video game, right? So a video game may start off and it may have a menu, and then you have a menu and you have, maybe your high score, your profile that you load, but then you move into a point in that game where you have like a game state, and then the game state will have things like players and enemies and things like that. Now, the question is, do you need the players and the enemies to exist when you're in your menu? When you're actually selecting the game? No, right? Or like when you're going into new levels or going into new rooms or whatever you're doing in your game, you may dynamically need to create more enemies to go against your player, and the way to do that is with pointers. Okay, so that's why we need pointers. Pointers are able to, and this is something that we'll discuss in our next tutorial, is how we can actually create audio tracks. So if we were running a real world application where we were trying to analyze a track, we would want to have functionality where the user would be able to select the track that they would want to analyze, right? So what we could do is that we could basically save all of that processing up until the point that the user actually chooses a track. And then once they choose the track, then we can actually do what's called dynamic memory allocation, which means that we actually then create an audio track instance, and then we do what we need to do with it. And then after we're done, we can actually just delete it or free it up so that we can free up those resources. Okay. So
okay.
Yeah. Any questions about that?
No.
Okay. So that's really it. That's really the lesson. So the big thing to get from this in summary is that a pointer and a reference are nearly the same thing. The difference between a pointer and a reference is that a reference needs to exist before when you're actually declaring it. So when you're actually declaring a reference, so if I say int b, like int reference b, it must reference something that already is memory allocated, like that. Okay, but if I do this, it's best to initialize it to null pointer. But the point is that it doesn't have to point. C does not have to point to anywhere when we actually create it. Okay, the best practice is to make it null pointer when we start, but that just means it's not pointing towards any space in memory. Okay.
So if we were to brief this code as like a summary, we're in the int main function, we're creating track in the class audio track, and in the function analyze track, which doesn't have an input, or I'm sorry, an output, because it's a void function. We're taking that whatever audio track. Let's say like later on in the code, the user inputs an audio track. At this very present moment, that hasn't been done yet. So there's nothing. We have this space, I guess we could say, this input box where nothing's in it, called the track. And it's taking that track and doing something with it. We don't have anything in this code for that, but as long as the track actually exists, then the void function analyze track will go through and analyze the levels in this case.
That's right. Yeah. So what would happen? So what would happen there is that if analyze track if you didn't have if your track was null pointer in this case, it would not. We don't have any code in here, but normally what you would do is you would have some sort of instance here where you would say pause the program, pause your track is null pointer. Something like that, where what would actually happen is you can actually set it up where your application will actually pause at this line of code, and it'll say, hold on, this is not supposed to be null pointer, but it is, and there's something wrong here.
I see. Okay.
Yeah.
I guess that'd be like the equivalent of, trying to pause an audio track that doesn't exist, or it isn't actually there.
Yeah, I mean, the pause is something, I don't want you to think about it too heavy at this point, but it's essentially something for us as developers, where what we can do is we can actually create little checks in our code to make sure that what we're doing is valid, and that that we're not trying to analyze a track that is null pointer and instances
Right.
like
Okay.
that. Yeah.
All right.
Okay.
Yep. Sounds good.
Cool. Well, that's it for this tutorial, and I'm looking forward to hearing people's questions and thoughts on this tutorial on Pointer so far. So please feel free to leave any questions, comments, improvements, and so on in the comments below, and we will see you next time.
See you later.